Cool, man. All right, so last class we were talking about solutions. We were talking about ties and nyes, the total ionic equation and the net ionic equation. Beep, boop, beep. And so now in the last part of this chapter, we're going to get into solution stoichiometry. So this is chapter 9. Which is solutions. Ooh, even less room. And we're going to talk about solution concentration and reactions. Okay? Conc is concentration. Is everybody on board with that? Oh, BT dubs. I'm probably never going to write the word solutions again. This is solutions from now on. So, when we talk about solution concentration, there's a couple of units that we use for solution concentration. The main one is called molarity. Okay, molarity is abbreviated with a daddy M, and that's going to be the most annoying part about this, because I'm going to tell you that every time you see daddy M, you got to replace it with what it actually stands for. So molarity is moles of solute per liter of solution. Okay? So, every time you see molarity, you need to replace daddy M with moles per liter. Okay? Every time. Now, I'm telling you guys this, and you're like, okay, cool, I wrote it down, whatever. But I'm going to tell you that the solution problems are the hardest for students because of this little thing. It doesn't seem like a big deal right now, but what I'm telling you is the key to solving all solution problems, okay? So, Daddy M is going to make it so that you have no idea how to use dimensional analysis, okay? What you need is moles per liter, okay? That is the key to solving all of these problems. Just as a reminder, when we're talking about moles of solute, right? What is the solute?
So thing that's being dissolved.
Exactly, right? So the moles of solute are essentially moles of the thing that's being dissolved, right? And liters of solution are the volume of solution relative to this amount of solute, right? This is always 1 liter of solution, okay? So this is another thing I think people struggled with in molar masses. When we start doing balanced chemical equations, I find that students really want to incorporate the balanced chemical equation into the molar mass in some exciting fashion. But the molar mass is, by definition, grams of that substance per 1 mole, right? This is the same kind of thing. So it's moles of solute per 1 liter of solution. Always 1 liter on the bottom. Okay? Never another number. Yeah. Are you talking, Jessica?
Oh, I just said at least it's consistent.
Oh, I'm sorry. I thought you said I have a question. Gotcha. Cool. Yes, it is. And I think hopefully that will be something that helps you out if you can remember that. Okay, so everybody with me? So now let's talk about how we will see this kind of calculation, right? How does this show up in calculations? I'm going to erase. So you guys okay with me?
Yeah.
Thank you. Okay. So let's say we have 25 grams of sodium chloride and 0.250 liters of solution are required. What will, the molarity of the solution be? Okay. Give you guys a minute to write that down. So let's start off with what are the units that the problem is asking us for?
Well, you gotta exchange grams for moles.
That's part of this problem solving strategy, but I'm just strictly talking about what unit are we looking for?
M.
Daddy M, but remember I hate Daddy M. We never write Daddy M because it's too confusing in terms of figuring out what you're trying to solve for, right? So what you're looking for is moles of NaCl per liter. Does that make sense, guys? Everybody with me? Cool. And we're given grams of NaCl, right? And so as Jessica pointed out, our first step is definitely going to be to go to moles of NaCl, right? And what piece of information do we need to get from grams to moles?
Molar mass.
We need the molar mass, exactly, right? So the molar mass of NaCl is 22.99 plus 35.45, 58.44. Back me up, guys. It's early.
Yeah, 58.44.
Cool. All right. So we have 25 grams of NaCl. What unit is going to go on the bottom? Grams, right? So I have 58.44 grams of NaCl per 1 mole of NaCl. So that cancels out my grams. And what's the last thing that I need? So I've got moles now on top. I need liters on bottom, right? Do I have a volume that I can put on the bottom?
0.250 liters.
Yeah. People don't like the blank up top for some reason. It really is disconcerting. So if that's problematic for you, just put a 1 on it, right? Everybody okay with that? This doesn't have to be a unit up top here, right? Jessica, do you have feelings?
What? What do you want the unit to be?
No. I'm saying, I'm sorry. I think you're freeze facing for me, so I'm getting a confused look. But are you?
Oh no,
you're
that's
cool?
just my face all the time.
Fair enough.
No, I have the answer already.
Okay, cool.
I'm chilling.
Anybody else have questions about this? We doing okay? All right. Cool. So what's the answer?
I got 1.7112 moles over liters.
Yay! So this, as an answer, would be equivalent to this. Okay?
I have a question.
Yes, Najma.
For the exam, can we write either way as the answer, moles per liter or the big M?
Yeah, that's fine. That's what I'm trying to say. Yeah. So no matter, as long as you give me one of these, either one would be acceptable. Yeah. Did you have a question, Jorge? I'm sorry.
I had the same question.
Okay, cool. Yeah. So these two are interchangeable, right? But the main reason why I'm telling you that I don't like Daddy M is not because it's not a valid answer, but because, again, when you have Daddy M here, if that's what's given in the problem and you need to use that to solve something, it's really difficult to figure out where you're trying to go unless you know to replace that with moles per liter. Does that make sense, guys? So let's do an example of that kind of problem, because I think that'll maybe help clarify what I'm talking about. Everybody comfortable with this one? Any other questions? Cool if I erase? Cool. All right. Okay, that was long. So a 1.25 molar solution is required. We need 50.0 milliliters of the solution. If the solute is sodium hydroxide, what mass of sodium hydroxide is required? So this problem is essentially the last problem backwards, right? Now we're starting off with the concentration, and we're being asked to solve for the mass required to make that concentration, right? So what are the units we're looking for? We're definitely going to need to change milliliters to liters. That's great observation. Yep. What are the units we're looking for? Grams of
sodium hydroxide.
Yeah, so knowing what sodium hydroxide is going to be kind of important here, right? Yes, anybody remember the chemical formula?
So I wrote down I wrote down NaHO, but I feel like I'm missing something.
You're not. You're totally killing it.
Whoa. Oh, perfect.
So Na plus and OH minus are going to give you NaOH, which is sodium hydroxide.
Bueno.
Killing it. What do you guys think of this pad? This thing's awesome, right? This is my Mother's Day present. I totally forgot to use it on Monday until after class, and I was like, ah, dang it. But it's rad. I love it. Such a nice guy, my partner. Okay, so we're looking for grams of sodium hydroxide. And we have a molarity and a volume. What the frick are we going to do? So I saw some strategies to take the milliliters to liters. I think that's a great way to start. So how do we convert milliliters to liters?
I literally always get this wrong. Like the fundamental thing I can't remember. It's either 100 or 1,000.
Milli, like a millennial, like a millennium.
1,000?
Yeah, 1,000. Does that help?
Millennial, yeah, that helps.
Yeah.
Because when I think of like milli, I think of million. So
I get that. I totally get that. Yeah. So, yeah, that's an unfortunate association.
It's fine.
Yeah.
I'll figure it out. Okay, so
Yes. So we have. I'm sorry, Kata. Just saw you. 1,000 milliliters for every 1 liter. So milliliters will cancel with milliliters. So now I have liters of solution. What should I do next? What did I say you should always do when you're given Daddy M?
write out moles over liters.
Yep. So 1.25 moles per 1 liter, right? Do you guys see how much easier that is to use in terms of dimensional analysis? You with me?
Yeah, what I did was I just rearranged the form.
You cutting out on me, Jessica.
Sorry. I just said that I rearranged the formula. So if it's M equals moles over liters, I just rearranged it for what we're trying to figure out.
Yeah, I mean, that's not wrong, right? But just seeing this, I think my point was that seeing this makes it a lot easier to figure out what the heck you're going to do with it. Does that make sense? Yeah. So in terms of problem solving, right, if we're trying to get to grams of NaOH, right, then the first thing we need to do is get rid of liters, right? We don't want liters around. Does that make sense, guys? So we have liters here, and we have liters here. right? So we can cancel the liters on the bottom. Does that make sense? So if I have 1.25 moles for every 1 liter, now I cancel out the liter of solution. Does it make sense why I wanted to cancel out the liters here? Because there's no liters in the unit that I'm trying to get to here, right? Everybody with me there? Cool. So then what's my last step to get from moles to grams?
You need some molar mass.
I sure do. I sure do. So 22.99 plus 15.999 plus 0.008. Oh, a bird just got inside our house.
Oh my god.
Sorry, guys. Yes, my daughter opened the back door, so now he's trying to get it out with my daughter being like, it's exciting. Yeah, so we got 39 grams for every 1 mole. Right, so moles cancel with moles. What you got?
2.499.
Let's go 2.5.
Cool.
Oops, not molar. Sorry, my bad. Oh boy, the units were right up here. Can you tell I'm distracted by what's happening? I can like see the other part of the house right now. Sorry, guys. Oh, the joys of working from home. Okay, so it's okay to switch units from the solution to the solute in the process. Yes, absolutely. In fact, you're going to have to do that a lot of the times. I think the bird's okay. I hope. He's just sitting there. It's so sad. Yes, that was the final answer. Sorry, Alex. Oh, I'm worried about him. So, what was the final answer? Sorry. Here, I'll write it up here. Hiya. Better? Questions about that, guys? Is okay? Okay. Can I erase? Yeah? Okay. So, let's get to the more complicated type of problem, which involves solution stoichiometry, okay? So, let's say we have 50 milliliters of a 0.5 molar NaOH solution, and we want to know what volume of 0.5 molar hydrochloric acid would be required to react all OH minus to water. Okay, so first thing I'm going to do for this question is I need to write out a balanced chemical equation. Okay, so I'm reacting this guy and this guy. Right? What am I going to form? So this is just another type of double D. Sodium chloride. Sorry, there's an airplane going over. And water. Right? Are we balanced?
Yes. It's already balanced.
Questions about how we got this balanced chemical equation?
How did you know that it was going to be sodium chloride as well as H2O?
So when you do the double D dance, right?
But you always know it's going to be a double D?
Yeah, because I have two ionic compounds. Anytime I have two ionic compounds, I'm double D in.
Got it.
Yep, great question. Any other questions about how we got that balanced chemical equation? Cool. Just so you guys don't freak out at me right now, let's just go ahead and mention that I wouldn't make you find the balanced chemical equation and do this kind of problem together, okay? Those would be separate problems. Does that make sense? I'm just trying to get you guys practicing all of that right now. Does that make you guys picking up what I'm laying down? So yeah, so that this isn't, I'm not going to stack everything together for you guys in a problem, but it's good to practice. Okay. So we have sodium hydroxide mixing with hydrochloric acid to form sodium chloride, and did I say sodium chloride over here? I meant sodium hydroxide. Anyways, form water, right? So what we're being asked is we want to react all of this OH minus to H2O, okay? So that means if we were reacting 1 mole of this, right? How many moles of HCl would be required to react all of this 1 mole? 1 mole as well. Do you guys see that?
Mm-hmm.
Does that make sense?
Because it's already balanced, right? So you're basically talking about the coefficients?
Exactly. That's exactly what I'm talking about. Yep. I'm just doing it in a really complicated way. Cool. All right. So I know if I needed 1 mole of this to react, or if I had 1 mole of this to react, that I would need 1 mole of this guy, right? So, I've got a lot of information. I've got This guy, this molarity, right? What's the first thing I do with Daddy M?
Put it in moles over liters?
Yeah, get rid of it. Now, when it comes to dealing with chemical reactions, you guys see how writing who the solute belongs to is kind of important here. Does that make sense? So I have moles of NaOH for this guy. And I know I have 50 milliliters of NaOH. And then I have 50 moles of HCl per liter of HCl. And I'm looking for the volume of HCl. So really quickly, what I want to point out here before we move on is that we talked about gas law stuff and when you know that you need to use the gas law. And we said one of those times might be if you have a volume, right? This would not be one of those times, right? And that's because we're dealing with aqueous solutions, right? Aqueous solutions cannot go into PV equals nRT. Does that make sense? Cool. Okay, so I'm going to show you the dimensional analysis way to solve this problem, and then I'm going to show you the quick and dirty way, and I'm going to tell you when it works, okay? So first, let's do it dimensional analysis style. So we're looking for, oops, sorry, NaOH. Oh, that's ugly. Right? So we're looking for this guy to be by itself. Do you guys see that? Cool. So if we really want to just do pure dimensional analysis style, we could just start off with this guy up top, right? And then cancel out everybody else. Okay, that's one way we could do this. The other way that we could do this is we could start off with the molarity and volume of NaOH, get it to moles of NaOH, figure out how many moles of HCl would be equivalent, right? And then cancel the moles of HCl in here to get the liters, right? So again, one of the harder parts to these problems is that there are multiple ways to solve these, okay? So I think because it's similar to what we've been doing, the first thing we can do is convert these milliliters to liters. You guys okay with that? So I have 50 milliliters of NaOH. And I know that there are 1,000 milliliters per 1 liter. So what should I do next? What unit should I put on the bottom?
1 liter.
Liters of? Uh-huh. And then I have liters of NaOH here, so I want moles of NaOH to be on top.
Why do I want to do the ratio, the molar ratio? Is it the molar ratio next?
Yeah, totes.
Cool.
Yeah, exactly. Right? So we know we don't want anything to do with NaOH, right? We want something to do with HCl. So we need to get out of NaOH and get into HCl. So we do that exactly using the molar ratio. So for every 1 mole of NaOH, we have 1 mole of HCl. Right?
And then you got...
Can you guys tell me what that equals so that I can just start cleaner down here?
Point 0.025.
0.025 moles of HCl. Coolsies? Red. So what unit do I need on the bottom here?
Mole HCl.
Yep, I need to put the moles of HCl on the bottom. Per 1 liter of HCl on top.
Bueno.
Madison, that's what this whole line equals. Does that make sense? Yeah, I just split it up because it's really hard to follow when I start doing dimensional analysis on more than one line. Sorry, guys. I'm working with a little bit less space, which I'm already bad at, so I apologize. Any questions about how we did this?
Would it be well, I'm just kind of seeing if I just continue on a straight line, I would put the 0.025 on the bottom, right?
No. So if you were just continuing on the same line, this thing doesn't come into it at all, right?
Oh, okay.
That's why there's an equal sign here, right? So I said this whole thing is equal to this many moles of HCl, and then I started a new dimensional analysis problem, right?
Okay.
So if you were just to extend this line, then you wouldn't have this. You would just have this step stuck up here. Does that make sense?
Yeah.
Cool.
I have more of maybe a half question.
Yeah.
So when I got this answer, my intuition was telling me it was wrong because it's so small in comparison to the other one, and I was like, that can't be right. Like, I did something wrong, so I redid it 3 times.
Yeah.
It came out the same every time.
So what do you notice about the units of this guy versus the units of that guy?
There it is.
Right?
Okay.
So if we were to convert this into milliliters, what would it be?
Probably the same thing.
It would be 50 milliliters. Yeah.
Okay, perfect. Bueno.
Either one of which would be totally fine for an answer. Right? That's an awesome point, though, because that's definitely something that I think students struggle with, is seeing things in different units makes it feel not intuitive, right? Like, this doesn't look like I think it should, yeah? Right. So never compare apples and oranges, right? Always compare apples to apples. Doop, doop, boop, boop. I'm going to show you the easy way, Kata. Is everybody okay with this? Can I erase? You guys are going to be really mad at me when I show you the easy way after showing you the hard way. Can I erase, guys? Cool.
Yes.
All right, so same problem we can solve